Okay, so the dreaded question. Okay, so this was given to me by numerous students who sat their non-calculator paper the other day and said, there you go Mark, have a look at that, sort that out. Well, I'll be honest with you, I most probably spent longer on this question than most people would have done on the whole paper. It is a bit of a toughie, no problem. No question. Okay, so here's the question. We have three circles and they're equidistant. They have a radius of 4 centimeters and they're all centered on the same line. And it asks us to find the area of the green shaded segment, as you can see there. So what I've done is I've spent about an hour doing this flip chart, and then I'm going to go through it with you right now, just to see. Okay, making sure we're live because I've tried this already and I just keep getting cut off. Okay, we need a plan. Well, let's look at these little segments here, and we can see that these segments are actually, they consist of a triangle. Oh, no, don't do that, Mark. There we go. A segment and another segment. There we go. I managed to get them out. So, what do we need to do? If we can find the area of these, so I'll just mark them. 1, 2, 3, 4. So let's find the area of 1, times that by 4, and subtract that from this complete circle. Voila, as easy as that, they say. So that's the first thing you've got to actually realise with this question, that you have a segment which fits in there lovely. That segment also has a triangle that sits in that very nice, and this segment here. Okay, so first things first, if we just look at this triangle, we can see that this is 4 centimeters, this is 4 centimeters, this is a radius from the center point, this is 4 centimeters, and so is this. This is an equilateral triangle. That's the first thing, and we know that all the angles add up to 180, so we know that each of these angles is 60 degrees. Very important. And the same with this. We can see that this length here is 4, this length here is 4, therefore the angle of this segment or sector is also 60 degrees. Okay, I'll just try and get that out again. Here we go. Okay, so there its constituent parts of this 1/4. We'll call that a quarter. Okay, so we need some formulas, and if you don't know these, you were never going to be able to do it. I'm not going to go through this one, but you would have been taught, or may have not been taught, depending, that you can find the sine and cosine and tangent of the common angles 0, 30, 60, 45, 90 using your left hand. And I encourage you to go on the internet, if you haven't, to show you how to do that. And the sine of 60, which is what we're going to be using, is √3/2. That's the first thing. We then need to find the area of this segment, which I've spelt wrong. Just typical. Let's just correct that while I look at it. There we go. Of this segment is the angle, which is 60 divided by 60 times pi r squared. That's to find the area of this. And to find the area of a triangle using the law of sines, so to find this area of this triangle, it's half a times b times sine c, and we know the area of a circle is pi r squared. So we'll go through these in more detail as we go through the problem. I'll just check to make sure we're still live. Yeah, I think we are. Okay, we need a strategy. Let's find a strategy. Okay, this is the strategy that I used. We need to find the area of a segment. Step 2, we need to find the area of the triangle, and we need to subtract it from this segment. If we subtract it from this segment, let me just draw that in badly. If we subtract this triangle, we will then end up, as you can see, with this chord, or this segment here. That will give us the area of that. If we then add that segment to this chord, so therefore it will end up looking like this, we will then have the area of this complete shape. We'll times that by 4 to find out the area of all of the quarters, and we will subtract that from this circle here, and we will end up with the answer. Okay, let's do that. So first of all, find the area of the segment. The area of the segment, as I said, is the angle, which is 60 over 60 times pi r squared. So we can see that 60 divided by 360 times pi times 4 squared. I've just simplified this. 60 is going to 60 once, 60 is going to 366 times. Simplify it as soon as you see the ability to simplify, okay, it's very important. 4 squared is 16, 16 pi, again here we go, 6 times this is just 16 pi times 1 over 6. Simplify this, we can divide this by 2, and we get 8 pi over 3. So that is the area of this segment. That's step 1. Step 2, find the area of this triangle and subtract it. We know the area, we've just worked this out. So what do we do? So the formula is again half a times b times the sine of 60. So AB, oh, should be AB here, not AB there, forget that. It doesn't matter because it's an equilateral, but if you take the angle and the two sides adjacent to this angle, you will end up with the answer. So it's half of 4 times 4, which again is 16, so that's 8, and the sine of 60 is the root 3 over 2. You can see I've done that here. And this also simplifies. 8 divided by 2 equals 4 times root 3. What I've now done is I've converted it into a fraction just by dividing it by 1. As remember, dividing anything by 1 doesn't change it. 4 root 3 divided by 1 is still 4 root 3. And I'm going to take that away from this 8 pi divided by 3. So we just 3 times 1, we just times the denominator and then cross multiply this, so 8 pi times 1 is 8 pi, and minus 4 root 3 times 3 is minus 12 root 3. So the area of this chord, this segment here, is 8 pi minus 12 times root 3 over 3. So we've got this, and we've now got this. What are we going to do now? So we're going to add this little segment here onto this like this, and we're going to now add a segment and a chord, and that will give us the shape of 1/4. So that's what I've done here. I've drawn this out, that this segment plus this segment equals this shape. Again, we'll just add them, so the answer to this was 8 pi over 3. The answer to this, as we just worked out, was 8 pi minus 12 times root 3 over 3. This is a simple addition because the denominators are already the same. So 8 pi plus 8 pi is 16 pi minus 12 times root 3 over 3. That bit, not too bad. We now need to times this by 4 in order to get the shape, the two shapes that we need to subtract out of the circle. Okay, again, not too difficult. 4 16s are 64, 4 12s are 48, and obviously the denominator is the same. So here's the bit that got me. Here's the bit that got me more than once, I must say. Took me nearly an hour to solve this, if not a bit more. As I said, we must simplify as soon as we see the chances to do that. So let's factor this numerator. Let's simplify that numerator. We do that by, I pulled 16 out, so that left me with 4 pi minus 3 times root 3. I've just factorised this numerator here. Very important. Okay, so we have now got this here, this answer here is for this shape times 4. Okay, all we've now got to do is find the area of a circle, and subtract this from it. Let's do that now. So this is what I've done. So the circle had a radius of 4 centimeters, so that's pi r squared, so that's 4 squared, 16 pi. Again, I've converted it into a fraction because we need to do some algebraic fractional algebra, and we're going to deduct that. We're going to take that away from the answer we've just done, which is 4 of these shapes. This is the answer. So this is what we do. Again, we have to multiply the denominators in order to get the same, so a common denominator. Cross multiply, 3 16s are 48 pi, 16 pi times 3, and obviously the rest of it remains the same because it's multiplied by 1. And again, the second thing that tripped me up, so if I put it in blue brackets here, but if you don't, you may get caught out by this double negative here, which I did. Even though I tell people watch out for double negatives, especially in fractional algebra, it caught me out no end of times. So what have I done? I've expanded this again, so we get minus 64 pi plus 48 times root 3. Just in these brackets I've just expanded this again. Okay, so last bit, final bit, we'll leave 48 pi as it is, and now I'm going to put the blue that I've done, the expanded version of this, in. And now we're on the home straight. 48 pi minus 64 pi is minus 16 pi plus 48 times root 3 over 3. This here is an answer. This is, but it's not in its simplest form. So what did I do? I pulled 16 out. I factorised the numerator. That left me, if I put 16 outside, that leaves me with minus pi plus 3 times root 3. But I've just put 3 times root 3 minus pi, because minus pi plus 3 times root 3 is you know, it's the bidness thing. Put your addition first. So that's the answer. That is the answer to this killer question. The answer is this here. Okay, so again, a little bit rushed. I wasn't actually going to narrate it. I was just going to post it as JPEGs, but I thought, no, I need to do some explanation. So again, if you think I made a good job of it, please like and comment. If you think I've got the answer wrong, if you think I'm barking up the wrong tree, please tell me so. If you think I could have done it better, etc., whatever, please like and comment, and like and share. And yeah, I'm going to now spend the rest of the evening helping others. I've got a couple this evening. They've got their GCSE maths exam coming up, 2 more, and so I'm going to be doing that. Okay, have a lovely evening to you all, and yeah, I hope that helps solve that horrible question 21 from this year's GCSE non-calculator paper. Bye for now.